Hey guys, it's Stark here, and I'm doing this tutorial. It's kind of a beginner's tutorial about Houdini, and this is mostly directed at effects artists, especially, I guess if you come from Macs, it's going to make more sense because I'm a Macs user, but right off the bat, I do want to thank two people because I've been pestering them forever, and I'm not used to a Mac here, so first I want to thank Johnny Farmfield here. You can see him with all the VOPs and stuff for helping me out, and you should follow him because he's very helpful. Loves Houdini, and I'll put the links down here. And then also this guy Matt Estela here, who has this awesome page that I pretty much I do have bookmarked, who does a bunch of these tutorials, and it's awesome because he has these animated GIFs and stuff. And he actually has a Patreon page, which I think everyone should definitely, if you're using his site, could donate to and throw him a couple of bucks, because this site's very, very deep. Like, goes into Vex stuff, which I'm actually going to go into a little bit today. Very basic stuff, and this probably looks terrifying, but it kind of is, but it's not. So anyways, let's get started. All I want to do today is actually just build like a simple dot network, which rigid bodies, if you're not familiar with anything. So I'm just going to start, and I set my desktop up like this. So I'm going to try to talk through everything as simple as possible because I know it's intimidating. It's intimidating for me still, so let's just get started. So the way that Houdini works, and if you've watched any video, they always start off saying this, is it uses things called contexts, which is kind of, look at it this way, if you're familiar with Macs or any other package, contexts are like, picture it as departments within the program. So right now we have our scene, okay? So everything is going to be contained obviously in this scene. And we're going to get started, and we're going to create a geometry node. Okay, and we're just going to call this rigid bodies. Okay. And there's this box here because I didn't actually drop down like a sphere or anything here. If I did that, you would see it. And let me shut this off. Or sorry, here. So I basically just dropped down an empty thing. Doesn't contain anything. So it's just a place marker. Now, within this, we're going to create a sphere. And I'm just going to try to walk through. Now, you're going to see over here how these are your attributes, or if you think about it in, I guess, other programs like channels, especially if you're familiar with Nuke or anything, it's just channels. So it's like, here's the position of all the points, and because it's, assuming it's NURB, so it's just a point, so it's at the origin, which is 0, 0, 0. But we are going to use not polygon mesh, just a polygon. And now you can see all of these things, which don't freak out. It's just telling you the position of every single one of these points right here. Okay, so I want to hop right into doing some Vex stuff, which is essentially coding, I guess you could say. And you could do this two ways. You could use Vex or VOPs. And I like doing it the coding way only because for me it works best, because it's easier for me to actually visualize it in my head for some reason. I don't know why. So let's do that. So first thing I'm going to do is drop down a transform. Okay, and this is just so it doesn't freak you out. I'm actually going to delete this in a second, but like a lot of this stuff's sort of self-explanatory. So like we just moved it up on X, and then We could rotate it. I'm using a trackpad, so I'm not really all that good. But yeah, just transform. Very simple stuff here. So we're actually going to use something called a wrangle node, and it's called we're going to use a point wrangle because we're actually going to work on all the points. Now, this is where I'm going to go into the Vex code, and I'm going to try to talk through this part. And especially if you go to Matt's site, this stuff will make so much more sense. So I definitely recommend going there. But a lot of this stuff you'll, especially if you're an effects artist, you should know, which is like position, color, things based off vectors, like 3 things. So X, Y, Z, blah, blah, blah. Very simple stuff. So we're just going to call this, I don't know, because what I want to do is I want to be able to sort of mess around on the, just the scale and the color. Just something very simple, just to sort of give an example. So I'm just going to call this color scale. Just not scale, sorry. Color scale. And then what we're going to do is the first thing is we're going to work on color, and we're running these over the points. Again, we're working on the points using a point attribute wrangle or point wrangle. So in Houdini, there's certain things that you can do to call out stuff that's like built in. If you're familiar with MaxScript, it's sort of, we'll just use that as a comparison, like sort of the same thing, not at all the same thing. But the thing about Houdini that is sort of intimidating is that a lot of stuff, and you'll see later on because I'm going to go into it, is that it's actually the cool thing that I like is that you could write expressions into input. So if you're familiar with like other programs where you have, let's say like just a thing where it's like, I want the scale to be whatever number, you could actually go in and write an expression into like every single thing, which is awesome because that means you could customize every single thing, like every tiny little detail you could do stuff to. And that's very powerful. So I'm just going to type right here, and I want you to pay attention down here. So if we just do CD, which the @ symbol is calling out, is creating an attribute, I'm pretty sure. So, and CD is just a color. So if you look here, it's going to be pure white because every single thing is 1. 1, 1, 1. Now, if you look, you'll see this CDR, CDG, CDB, so red, green, and blue. So with that in mind, what we could do is we're going to go ahead and actually do CDR equals, and then we're going to create a channel. And what this is, we're just going to call it red. And right away, I'll show you what's kind of cool about this. We'll hit enter, and then you could hit this button right here and automatically create a slider. You could see that as I slide it, it's creating different colors across the points. Okay, so we're going to do that for CD. So we want to do it for the green. Sorry, I have a microphone in the way here. So give me a second. And you can see that's changing color as I type this. And I can copy and paste it, but I don't know. I feel like typing it, you can see what's happening. And then we'll just hit this. And I definitely messed up because I did green and not blue because I can't talk and type. So hit enter again, and then we'll hit this. And then, so you see, okay, I forgot one thing here. Just wondering why it wasn't working. I had everything correct. It's because I wasn't working off of this guy. So as you can see, we have sliders now. And what we could actually do is we could actually I guess right click or double click or whatever, and we could go to the we could actually edit the parameter interface. And what's kind of neat is we could highlight these, kind of make our own little UI thing, and we could let's see, I think right click, and then we could just put parameters in new folder, and we'll call the folder obviously color, and then hit apply, accept, and it obviously didn't do what I wanted it because I did not put it into the root folder. If I could click it. And okay, and it hates me. Let's try this one more time. It's in the root, and there we go. Sorry, I didn't put it in the code thing. And then there we go. So we have color. And what's cool about this, we can always come back to it. Now we're going to do the scale. So this one might be a little weird, and I'm sure there's a better way to do it, but just the way I think of things is through math, so it's just easier for me. So one of the things we're going to do is, if you look up here, these guys are initialized, and what initialized, I'm trying to think of a good way to explain it. We could say initialized means that it's actually an attribute. It's held within the object, I want to say. It's like turned on, so it's showing up here. So we're going to actually do something where it's not. So we're going to call it a float number. And if you're not familiar, and we're just calling it scale because I want to be able to mess with the scale. So we're again going to use the channel trick here. And I am deathly afraid of spelling everything. And you'll see it did nothing. But for people that aren't familiar with float numbers and integer numbers, a good way to do this, let's just pull up a text wrangler, I guess. This guy. An easy way to look at it, general purposes, let's say a float would equal like 1.0, 3.5555, blah, 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 and then an integer would equal like 1, 9, 10, 100. So just a general rule, there you go. You just learned something. Okay. So now what we're going to do is, remember I said everything is based off these points. Well, what we're going to do is we have this guy channel scale, and I'm going to hit this guy again, and it's doing nothing. Okay. And one of the things I want to do is, because I'm going to do it by multiplying. I'm going to actually just reuse this thing, is I'm going to go into the, let's see. Edit parameter interface again, and then scale. See how the range, I want it at 1, because if I do 0, and we'll do like 5 as the maximum. If I do 0, obviously 0 times any number is 0, so it won't show up. So now our minimum number is 1, and then it's 5. Now, basically all I'm doing is, and this might make sense here, is we're going to use our points now. So again, like one of these built-in things, P, X, Y, Z, okay? So it's just position, I think it's position, I'm pretty sure, not points. But these are the position of the points, so just keep that in mind. So all we're going to do is take it, we're going to say the position of X, or of each point each point's x value times scale. Once I actually type it correctly. Now you see obviously 1 times that, and then see as I start to multiply it, but obviously we don't want footballs, so I'm just going to copy this twice. Okay, here. And we're just going to do y. This is hell on a trackpad, by the way. And then I'm hitting Command Enter too. I'm assuming that just makes it go through, but see, here you go. And I actually think I want to. Well, I'm gonna actually edit the interface anyway, so I think I want to do something like 0.5. Let's do 0.25, whatever. And then right click, and then we'll just go ahead and put in a new folder, and we'll call this one scale. And I guess a more appropriate name would actually not be scale, it would be multiplier. But for this, you guys get it, so you're in the know. And I actually put this, I don't want it into a tab. So it's like I just did the same thing. And it's in a tab because, of course, it's never happened to me. Assuming it's going to be, let's just try simple. Yeah, okay. So there we go. So now we have our size. See, it's not terrifying. I mean, the code could be, but it's not. And I'm just hitting L to do this, and then so next thing we're going to do now is we're actually, because what my plan is, I just want to make these spheres because I want to keep this simple, and obviously I don't even know what the running time is right now, but it's, you can see how it is adding up. I just want to take the spheres and then I'm going to put it onto like a ring, and then I just want to add gravity and then a simple collision, and then we'll be done. So what we're going to do is actually create a circle. Okay, simple enough. And I have this guy right here because it's basically locking that. So right now I'll just get rid of this. And then what we want is, we're only using this guy for its points. So we're just going to do polygons, and this is exactly what we want. So I have to add a transform because I don't want it to be like this. I want it to be in a perfect circle, or not perfect circle, but you know what I mean, on its side. So and for Max users out there, this is Z is up, not in here. It is scary. Now, the one thing we need to do, which is quite obvious, is we need, again, everything's points. I want to take this sphere and I want to put it around. Okay. Now, when I say everything points, what I mean is everything are points. So you could see, I think you could see it. Hopefully you could see it. You could just see the number, each point number. And if I actually went back to the sphere, you would see each point number, which coincides over here with every single attribute. Now we're going to use something called a copy sop, or copy sop. I guess it's copy sop. Everyone calls it copy sop. And the way I look at these is sort of, if you look at it, because we're going to use a merge, but it's not exactly the same thing as like a nuke, but is you're taking one point of data and then you're just copying it over. So as you can see, Here we go. But the problem is now it's in the middle of the ground. So all we could do is just add another transform. And then there you go. Now, this is kind of boring because it's just, I mean, we could just do the spheres like this or whatever, but what I want to do is I kind of want to add some variation in the height. So I'm going to go ahead and add another an emitting tab, just like a nuke, to bring these up. I'm going to add another point wrangle. I'm going to, not go into the sub network, I'm assuming. And I'm just going to call this noise. Okay, and all I want to do is, and this is where some math stuff's going to come in, I just want to add some noise into the different height. And we're actually going to use sliders again, because they're very helpful. And I think that's neat that basically for every single node, once you have it set up, you don't have to keep going in and changing the code, especially on this trackpad. And I'm on a 12-inch MacBook right now, so I'm not exactly, it's not massive. The screen is not, so it's way easier just to have sliders where I can see these numbers, especially in the contrast to black and white right there. So what we want to do is, again, it's going to add an uninitialized thing, and we're going to set up, because noise has a frequency, you know, we're at a channel, and we're just going to call this frequency. And then I want to add a random number. So I'm going to call it random num, and that's what it is. Now, what's cool is you could basically take this, you could take one number and then put it within a number. It's almost like you're pre-comping it, and if you're used to programming, obviously it's super simple to you. If you're not, maybe it's not, but this, maybe you'll have an aha moment here. So I'm actually taking, because what a noise is, this is one of the built-in Vex functions, which is you have noise, and then I could put any number I want, but so I don't have to keep changing. I'm just adding a slider. So you'll see the reason I'm doing this. So for right now, let's just put the name in, which is frequency. So it's the end of that right there. And then I'm going to go ahead and I'm going to add another thing, because one of the things you'll see is I want to add a divisor. And this is just to kind of act as sort of like a normalizing thing, just so that the noise doesn't get out of hand, which you'll see in a second. Oops, hit the volume button. Sorry. So I'm just gonna add a channel, and then divisor, and then we're gonna write out our little expression. So we're taking its Z position. Now keep in mind, it's we rotated it. Okay, so I'm assuming the transforms are different. I mean, they are, because it's not on the Y. So now I'm going to take a random function and not type random. And then I'm actually just going to say, again, remember I said everything has a point number, so I'm saying every random point number, okay, times up here this random num. And then I want to divide it by the divisor, and we'll call that a day, and hit these guys. So basically everything is zeroed out. If I start turning up the frequency, it's divided by 0. So you can start seeing, and did I hit Z? I think I actually, give me 1 second. I think I want to go ahead and let's try X. And this might, there we go, I'm sorry. Oh, you know what it is? It's because I did it after the transform, not before. But, and this is what this divisor is doing, is basically taking that. And let's actually go in here. Change it back to Z. And I think that's good. Again, I could change I could go into the edit parameter thing, and let's just do that. And then let's just move it up like 7, just so it's a little higher up. See, so I hope this is making sense now, because I know it's kind of weird, but so now basically we have just this, it's sort of one single piece of geometry, but it's not. So we need to break it up, okay, obviously. So what we're going to do is add something called packed, it's packed geometry, but it's called an assembly node. And this is just going to go ahead and this is going to separate everything. So now these ones, actually, I should just show you this. So if I don't do packed geometry, it's just one object. So let's just move over here, and I'll come back to that. And we're going to go ahead and make just a grid. Okay. And you don't have to do this, but I think it just makes it more interesting. And a grid's a grid, nothing special. It's just a plane. Let's do something like 25 by 25, just so that it encompasses this guy. And then we'll add like 20 by 20, and then we're gonna add a mountain node, which is equivalent to it's just noise, obviously. And then we'll just, I don't know, kind of want it to be like, I'm gonna actually go ahead and add a smooth. And I'm actually happy with that. It's pretty good. So I'm gonna hit L. Now, here's the thing, is now these things are two separate objects, right? So they're two separate objects within this. Now I'm going to just go ahead and create a DOP network. Now this would be, a DOP network would be, especially now because I've started really using it on version 15. A DOP network is like rigid bodies, soft bodies, stuff like that. And they merged it with hops, which are just particles. So again, if you're familiar with 3D Studio Max, it would be the equivalent of having just thinking particles, put it that way, or P-flow, especially now with just regular particles, dumb particles colliding with rigid bodies and stuff. They merged it, which makes sense to do that. So it's one thing. So it's just a DOP network, and then I'm going to hit C and then color it red because I've been doing that and I don't know why, I just have. And all I'm going to do is I'm going to add a null. I don't even know if this is the proper way to do stuff, but like to me, it's just a good thing to sort of cap it. And I'm going to just call it spheres. And then right here, I'm actually going to, we're going to call this packed, and I'll come back to that. So we'll go ahead here and we'll add a null. And again, a null is just a non thing. And I broke that chain, I'll call it, and we'll just call this ground. Then I'll reconnect these. I'll hit L, which will move everything out of the way. And you're like, oh no, where'd it go? Again, I'm not on that. So again, if I hit here, you're not gonna, well, you are gonna see it, I guess. No. Okay, sorry, I still have that selected. That's why. Okay, so everything is still here. It's just not connected. So I have an empty dop network, and here's the output, and this is just to write things. Okay, so or to like cache it out. So I'm gonna delete that because I'm not gonna cache it out, and I'm actually gonna change my timeline to 100 frames because that's good. So one of the first things we want to do is add a terrain object, which, if you guessed it, would be our ground. And now it's brought in here, and you can see this thing. And this is kind of cool where I actually like this a lot because, I don't know if you're familiar with thinking particles or a lot of rigid body systems, you can't just use a plane, sort of. Like, even though you want to just use a plane, you have to extrude it and then kind of just not put in the render, where with this, it's sort of doing that automatically, which is cool. And all I'm going to do is set up these bounce stuff and less friction just so that everything's more crazy, I guess. So now we need to add a solver. So we're just going to, this is a static object. So, and it's the ground. It has a, so if it was something else, just like, I don't know, anything like a shelf or something, you would use it. But this is a special case where I'm using the terrain object. So keep that in mind. And anyways, but you can see that I'm starting to import it. Now, if I was using just active stuff that was like one giant thing, which this is, I'm coming back to it. I'm going to bring in, let's go back to the DOP network here. I'm going to actually import the, so let's say we had one object. Usually a lot of times you could just have, like, if I just wanted like one thing that hit something and it fractured, you could use the rigid body object. But this is made up of it's made up of packed objects. So what we need to do is add a rigid body solver. Okay. And it would help if I selected my spheres, and now it's in the DOP network. So, and if you look at the context up here, I'm in dynamic. So it's sort of like everything is just in a node. It's weird. It's sort of like, just look at these things as sort of like different departments, I guess. Like, and that's why they call it like a pipeline in a box. It has everything you need, and you can make whatever you need. So we're in the DOP network here. Now, what I'm going to do is go to the merge. Okay. Now, what it's going to do is exactly that, where in Nuke, it would merge it, you know, it would do its like a blending mode, After Effects, stuff like that. But here it's merging them together so that they're doing it. And you can see nothing's happening because I don't have any force on anything. So nothing is going to happen. For right now, I'm just going to add a gravity force. And you got it here, you got it here, and I think no, because that was an input or something. I don't know. But we'll add it here. L, and then I did something where let's double check ground. And it is not working. Hold on. I know people are screaming probably at their screen like, "Oh, you didn't do the whatever." What I'm going to do is actually just delete it, because why not? Okay. And let's actually go here. Rigid body. objects. That's probably why he's giving me the warning. So there we go. Very simple. I think actually the reason why I have it doing what it's doing is I used to do it another way, I'm pretty sure. So what if we did a cusp edges? I don't know. Let's see what happens. Okay, I'm not gonna mess with it, but there's another way where you can make it where it's only one object, and you can see that nothing's actually showing. So let me actually go back to here, and I'm gonna name this guy packed, and let's make sure everything's good. It's not good because I screwed it up over in the assemble node. And so now what's happening is it's only exporting these. It's ignoring this. Now, you're probably like, well, why would you want to do that? Well, what if I just want to use a low-res thing as my collision object, and then I want to go ahead and actually, that's what we'll do. I'll explain this in a second. So we want to use this where it's not that high resolution, you know? So stuff like that where it's like, okay, this is basically our proxy collision object thingy that we're going to use. Now, I want to actually make this more interesting because, gravity's gravity or whatever, but I'm going to delete that, and I'm actually going to do a pop force, which we could go here. Okay. Now, again, particles, pops, of course, is you could use pop forces, so like regular forces within the dynamics, or the DOPS. Sorry. I'm not up to speed yet with all the ops. So I'm actually going to use a thing here. So I'm going to just do -1. Now, it's going to go really slow, obviously, but gravity is the actual force thinks like -9.8, blah, 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 blah. So we're actually going to call this out and then just do force, and then we're going to use a fit 01, and actually I feel stupid because I closed out of what the fit 01 does, but from memory I think what it does is it'll take numbers and then randomly choose from this whatever the number is, it'll choose a number between them basically, and that I could be wrong. I'm so sorry for that. Now these are basically IDs now. So we don't want to operate on the points. We actually kind of want to operate on the object itself, sort of. So now we're just going to use the ID. So which basically sphere, and then we'll do like 9.8 because again you see force, and it's going to multiply by each of these. So the 0, there's going to be no force on the X, so the sides, or the Z, so none of the lateral movement forces basically, and then because it's going to multiply it by that, whatever the number is, by -1. So, and then let's just do like, I don't know, what, 35? And then, let's see this not work. No, there we go. So now all it's doing is, each of these has sort of its own special gravity. Now, here's the cool thing about Houdini, and this is where they talk about it a lot, where it's procedural, which is, I'm just going to hold on to this. Actually, I think this is called the Wildcard, so it's anything within it. One of the things I want to do, because I want to show you some of the stuff, especially one of the things I like to do is, because it's procedural, I could just go back and then resize it. So it's still going to work. And then just like that, I kind of want some of these guys to fall off. Okay. And I'm going to make it even smaller. I want to do, let's try like 7 by 7. There we go. And then I want to bring down the height. And let me should probably do this not while it's slimming. But I think that should be good, because I do want these guys to come off the side, because actually I'm saving it because I want to show you something that's cool once I'm done. Okay. I'm actually going to shut this off and type packed again, because I'm going to make that guy a higher resolution. But basically, we're done in here for this again, because I'm keeping it basic, and I'm already, I don't even know what the time is of recording, so there you go. So now we're gonna go out of here, okay, and we have this ground. Now what I want to do is, we have the smooth, okay, and let's go ahead and add I'm just gonna do another smooth, because and this is obviously not going to be super noticeable. We could add like, I don't know, 20. So it's like even extra smooth. I'll just stick to 0.1. I don't want to mess it too much. Now, because this guy, see, it's only outputting that, we could actually go ahead and add a merge. So it's sort of falsely faking it that it's colliding with a huge super smooth fancy thing. And let's just change the color. I'm just gonna not do a pop network thing here, and we'll do, it's a nice contrast color, and there. I mean, that's like really blue, but let's do something lighter. There we go. Now, the very last thing I want to do is something that I was actually obsessed with. This is one of the first things with it, which is a condition, and I do this in Max all the time, which is, as long as these things are here, it's gonna have to keep calculating all these points. Now, this isn't really anything special per se, but it's just something that I like to do, I guess, as like an effects thing. So we're actually going to add another, right, a point wrangle. Just type wrangle. And then we're going to write a condition, which, If you're not familiar with what a condition is, look at it like anything else in condition. If this, then that, basically. If you are bad, you're going in timeout. So we're going to write if the position of P, or position of its Y value is, let's do like less than, so that's less than. Let's do -5. Okay. Then it's going to remove the point. And I'm pretty sure this activates it. So it's else don't do anything. And it's going to remove the point number. And I probably said that wrong. And then close it and boom. Now you can see once it hits that, but we could get all fancy again. Let's do a float. Let's just call this Thresh, because that sounds cool. Channel Thresh. Close it. And then if it's less than Thresh, which it's 0 right now. So if it's less than, it'll do it for all of them, which I guess isn't great. But here's the thing, though, that I actually, you'll see that starts deleting the points of these, which I guess you could, I mean, I'm sure you could use that for something. But what I actually like about putting it at the bottom like this is that then I know what the bare minimum is, because I want it to delete at a certain point, but I don't want it to delete before this line. So that at least gives me a good visual indication of it. So we'll go ahead and let me just edit the parameter interface, and then I just want to take the threshold and then let's do like -5, and we'll do accept. So now we can start to see, so we start going down, where's that minimum? And so it's sort of like once it goes out of the camera view, then you're good to go. So see, it's kind of neat. And we'll just go ahead and play it back. I'm going to hit L, so it looks all fancy and messed up and not as pretty. But whatever. So here we go. And I'm sure I'm going to say, oh, it's that easy. But I mean, it kind of is. Like, it's, what I like is that, like, I could always just keep going back. Like, I could, like, even with this grid, it's like, okay, I could change the, and I know everyone's gonna say like, oh, it's not that big a deal. You could change the transform or the rotation of it, but like, let's do like, I don't know, what, 25? Did not want to do that. It's probably gonna actually delete the, no, I went low enough, but let me hide the grid. Oh, it's because I am there. And remember our slider thing before? I mean, that's gonna kind of screw up because they're colliding, but do that. Could actually add more points, and it'll update on the next. Now, what's even cooler, I'm not gonna show you, but you could, because it's within it's inside of this geometry node. Is that I could basically copy it, but what I could do is like, say there's all these settings, and say, I don't know, like you have to hand this off to someone. Not that I am anyone to talk to hand it off to anyone at this point, but you could actually take all of these settings you have. So I could have like sphere color and sphere scale, and then I could hide all of this, and then I could just put all the sliders that someone needs. You could have a tool where it's only the things that they need to see, so they don't actually ever have to go within the network. So I could have something where it's like size of the grid, angle of the grid, blah 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 blah. So I'm gonna call that quits. So if you guys want to contact me, my Twitter is at mstarktv, and I'll have a link in the bottom. Again, you guys should check out Johnny Farmfield and Matt Estela, especially. Awesome site. He helps a lot. Helped me a lot with, I would say, 90% of all of the stuff on here for it to make sense. So I hope the next tutorial will do some cooler stuff, but I just wanted to kind of give while I'm able to still communicate ish, just give my words. So thanks guys.